model and conceptual modeling. We mentioned earlier that the schema is written using the data definition language. In fact, it is written in the data definition language of a particular DBMS. Unfortunately, this type of language is too low level to describe the data requirements of an organization in a way that is readily understandable by the variety of users. What we require is a higher level description of the schema, and that is the data model. It is integrated collection of concepts for describing data, relationship between data, and constraints on the data in an organization. A model is a representation of real-world objects and events and their association. It is an abstraction that concentrates on the essential, inherent aspect of an organization and ignores the accidental properties. A data model represents the organization itself. It should provide the basic concepts and notations that will allow database designer and end users to accurately communicate their understanding of the organizational data. A data model can be thought or include three components. These are the structural part, consisting of a set of rules according to which databases can be constructed. Second is the manipulative, manipulative part, defining the types of operations that are allowed on the data. These include the operations that are used for updating or retrieving data from the database and for the changing the structures of the database. And the third is the possibly a set of integrity rules, which ensure the data is accurate. The purpose of data model is to represent data and to make the data understandable. If it does, then it can be easily used to design database. To reflect the answers part, architecture introduction in this section, we can identify three related data models. The first one is an external data model to represent each user view of the organization. The second is the conceptual data model to represent the logical. The third is the internal data model to represent the conceptual schema in such a way that it can be understood by the DBMS. There have been many data models proposed in the literature. They fall into three broad categories: the object-based or data models, record-based data models, and physical data models. The first two are used to describe data at the conceptual and external level. The latter is used to describe data at the internal level. The object-based data model, used to conceive such an entity's attributes and relationships. An entity is a distinct object, a person, place, or thing, concept, or event in the organization that is to be represented in the database. An attribute is the property that describes some aspect of the object that we wish to record, and relationship is an association between entities. Some of the more common types of object-based data models are entity relationship, semantic, functional, object-oriented. The entity relationship models has emerged as one of the main techniques for conceptual database design and forms the basis for the database design methodology used in this book. The second is the record-based data model. In a record-based model, the database consists of a number of fixed format records for possibly different types. Each record type defines a fixed number of fields, each typically of a fixed length. There are three principal types of record-based logical data model. The relational data model is based on the concept of mathematical relations. In the relation model, data and relationships are represented as tables, each of which has number of columns with a unique name. The network data model. Data is represented as a collection of records and relationships are represented by sets. Compared with the relational model, relationships are explicitly modeled by the set, which become pointers in the implementation. The hierarchical data model is a restricted type of network model. Again, data is represented as a collection of records, and relationships are represented by a set. However, the hierarchical model allows a node to have only one parent. A hierarchical model can be represented as a tree graph with record appearing as a node, also called segments, and sets of edges. And the physical data models describe how data is stored in the computer, representing information such as record structures, record orderings, and access paths. There are not as many physical data models as logical data models. The most common one is being the unifying model and the frame memory. Conceptual modeling. Conceptual schema is the core of a system supporting all users' view. From an examination of the tree-level architectures, we can see that the conceptual schema is the heart of the database. It supports all external views and it turn supported by the internal schema. However, the internal schema is merely a physical implementation of the conceptual schema. The conceptual schema should be a complete and accurate representation of the data requirements of the enterprise. If this is not the case, some information about the enterprise will be missing or incorrectly represented, and we will have difficulty fully implementing one or more of the external views. Conceptual modeling should be a complete and accurate representation of organization data requirements. Modeling is the process of developing a model information used that is independent of implementation details. Result is the conceptual data model.